Our topic is how can containment save lives and money? And this webinar has been kept together with Thurne and Lugaia. When we planned this webinar, we were thinking how to describe this word containment, because it's maybe a little bit unclear and difficult. So we ended up to these two pictures that we think describe it quite well. Containment is balancing. You have to think your own safety and also environment safety. And both of these need to be in balance. If there is some mistakes or risks, you need to take care of those. Otherwise, the result could be very, very dangerous. So today we want to talk single-use containment technology, advantages, disadvantages, and limitations. So my name is Sami Haasto and I'm moderator today. I have worked here Thurne now 3.5 years, and I'm responsible closed powder handling solutions, and of course also containment. On the Lugaia side, you will be given a presentation by Michael Schweizer. Michael has worked at Lugaia as a sales manager since 2015. Lugaia and Thurne started their cooperation around 7 years ago. Lugaia locates in Switzerland, Thurne area, which is very nice area mid of Alps. Here you could see your Thurne contact persons for each country. So Finland, me, Sweden, Norway, Magnus, Denmark, Rafi, Estonia, Latvia, Lithuania, Andris, and Poland, Dorota. Please feel free to contact us if you have any questions. And follow us Facebook, LinkedIn, and YouTube. So let us begin. Welcome, Michael, and please go ahead.
So thank you very much, Sami, and welcome everybody from my side as well to the Thurne webinar. As Sami already explained, my name is Michael Schweizer and I'm responsible for the sales at the Lugaia headquarters in Switzerland. I'm pleased to make the presentation to learn about advantages, disadvantages and limitations of single-use containment solutions. First of all, we want to learn what are flexible single-use technologies. Flexible disposable systems are single-use containments that are not permanently installed and, as the name suggests, are disposed and replaced after use. The single-use containments act as a packaging for hazardous product in the sense of primary or secondary packaging. Single-use containments are used to protect the operator, the environment and the product itself from contamination while working with dusty powder. So what single-use containments are available on the market? Here we have flexible single-use isolators, single-use transfer systems, flexible enclosures and continuous liner systems. In the following slides, we will get a more detailed overview of the different systems. First of all, we have the flexible single-use isolator, and the question is where we can use these systems. Basically, the isolator is used to protect the operator and the environment for any handling with toxic substances. More or less the same operations can be made with a flexible isolator rather than a rigid isolator. Of course, with some advantages and disadvantages of each. But the main applications are sampling from drums, dispensing operations, apparatus discharge, or charge and filter change. As a next single-use containment, we have the transfer systems. Rather using rigid containers, here we have single-use transfer bags with different containment connections. Basically, the transfer bags are used to transfer substances into process plants, discharging and charging powder from different apparatus. Similar to flexible single-use isolators or flexible enclosures. Contrary to single-use isolators, the flexible enclosures are not a standalone system, but installed on any machine or process point to ensure containment. These are well customized and mainly used to upgrade or improve existing apparatus. Here we have an example on the left side showing the sampling procedure with a flexible enclosure. On the right picture, a flexible enclosure to protect while opening the granulator. Finally, we have continuous liner systems. Continuous liners are basically used to continuously pack powder in a contained way. In this case, we talk about primary packaging because the product is in direct contact with the film material. Continuous liners can be also used as a log transfer in case they are installed on a sideboard of a flexible or rigid isolator. The old technology was to just wrap up a tubular film on a tube. The handling therefore was not easy and it was not possible to wrap up many meters on the discharge tube. Here with the continuous liner, the specing folding technology now allows much easier installation and a much higher capacity on a less as possible space. Okay, all the containment systems shown before are completely tied in itself, but every single-use containment needs to be closed and separated somehow. As this is the weakest point of the whole containment system, it is very important to use a suitable closure system. Here we make the difference from mechanical and thermal closure systems. For the mechanical closure systems, there is a simple solution with a cable tie which not offer a high containment level. For higher containment levels, there are special crimping systems like on the second picture from the left that Lugaia offers. This can be manually or also automated as shown in the rightmost picture. If using special crimps, we can reach a containment level of at least OEB5, means less than 1 micron per cubic. When we look to the advantages and disadvantages, on the plus side, we have a very easy handling. There is no temperature influence on the film or on the substance inside. It's very universally applicable, can be used in ATEX areas, or we have low investment costs. On the negative side, we have higher consumable costs, and it's manual operated and thus cannot guarantee always a uniform closure result. Then it is also possible to use thermal film sealing systems as shown in these pictures here on the presentation. Here on the plus side, we have the high containment level and the uniform closure result because it is controlled over the machine. On the negative side, we have to take care because some substances do not allow welding. We have higher investment costs, especially for ATEX executions. And finally, it may be difficult to handle because we have to take care that the film material is in a flat way without wrinkles and that there is no product on the inside of the film. Now we are looking for the different film materials that can be used for single-use containments. So the question here is, what are the types of materials that are used for the single-use containment solutions that I showed you before? For isolators and flexible enclosures, mainly PU, polyurethane is used because it has very high mechanical resistance and clear visibility. That allows a high flexibility and ergonomic handling while working with a single-use isolator, for example. The PU material is available in anti-static versions and offers FDA approval. We just need to take care because the PU material is not resistant to all solvents. For the other single-use containments like continuous liners, we have PE polyethylene. For example, the continuous liners are used as primary packaging. Therefore, it is important that the type of PE and the approvals fit together with the substance and the requirements of the discharging environment. PE is available in many different types with different approvals. For final packaging, mainly a PE without any additives or pharma-grade EP and USB approvals is used. For ATEX areas, there is a PE with anti-static or electrically conductive properties. When designing a single-use containment, it is important to know the restriction of containment level for a dedicated process. In order to use the correct single-use containment for the related application, we can say that open bags with local suction can be used for OEB1 up to OEB2. For OEB2 up to OEB5, we can use single-use transfer bags and continuous liner systems. Single-use isolators are mainly used for OEB5 applications. So a combination of the two systems may allow to reach a higher containment level as well. For example, a continuous liner which is placed inside an isolator. Yeah, in any case, single use may be a good alternative to rigid systems under consideration of some advantages, such as better operability, reduction of cleaning effort, and waiting times. But of course, the user has always to consider the consumable costs versus the investment and running costs for the cleaning and the revalidation. Here on the picture, we see a comparison of the rigid and single-use systems. For different reasons, here the customer decided to switch from the existing rigid system on the left side to the single-use version on the right side, offering the same functionalities. Okay, so next slides. The next slides will give you an insight into a case study we realized for a containment project with a pharmaceutical customer in Germany. When designing a containment solution, it is very important that the customer and the supplier work closely together. First of all, it is important to know and to define the process and the requirements. Here in this case, the requirements of the customer was to manufacture OEB4 compound. It is a straightforward manufacturing process for film-coated tablets. The existing equipment does currently not achieve the OEB4 containment level, and therefore some retrofitting is required. The first process step, dispensing, is currently handled under a laminar flow and needs to be upgraded to reach OEB4 level. It is intended to use a suitable OEB4 transfer system to transfer the product from one to the other equipment for the following process steps. So the process steps in detail are the API coming in drums for the dispensing over a single-use isolator. After that, we use a single-use transfer system for the next step to the granulation. From the granulation as well, transfer system to sieving. After that, to drying, then again to sieving. After that, to blending, compression, and finally to film coating. So this is the whole process that needs to be worked with any single-use system. In this picture, we see an overview of a part of the current production with different apparatus like screener, dryer, granulator, and so on. Some of the transfer steps are currently made with vacuum powder transfer system. The problem here is an exposure of powder while disconnecting the tubes. And it is intended to replace the tubes by a single-use transfer system to reach OEB4 level at least. Now we go back to the first process step, dispensing. If you remember, currently it takes place under a laminar flow. In order to improve the containment level, we proposed a single-use isolator. Therefore, first we made this conceptual design. For the single-use isolator, we do not have any standard executions. This means every isolator is designed according to customer requirements in different dimensions and with different connection possibilities. The conceptual design is very important to define the design together with the customer and serves as a suggestion and basis for discussion. In detail, this isolator has a connection on the backside to connect the drum, which brings the API. Furthermore, we have a continuous liner on the left side, which allows to transfer waste, samples, and equipment like the balance inside in a contained way. A small balance is placed inside the isolator to take samples of the API. The API is then transferred through the continuous liner out of the isolator. As soon as the drum is connected, the API can be transferred through the isolator into the transfer bags, which are connected on the left side underneath the isolator. The transfer bag itself are sitting on a balance as well to make the appropriate portions. Looking to the isolator in more detail, the isolator is made of PU, which offers a very high tear resistance, clear visibility, and flexibility for ergonomic work. The isolator is really easy to attach in a metal framing by tabs with push buttons. Even a replacement of the isolator can be done within about 20 minutes, also because no cleaning and revalidation is required. Furthermore, the isolator is having a magnetic base plate at the bottom. Because the ground of the frame is made of a special magnetic stainless steel, the isolator with the magnetic base plate can be attached to it and serves a flat work platform which does not move around. Every isolator is equipped with an integrated H14 single-use filter, which is used for breathing while working with the isolator. If a ventilation system is required for inertization, for example, so it's also possible to integrate more filters in the isolator so that we have an inlet and an outlet and as well one filter to take measurements. Also, different interfaces for media supply are possible to integrate in the isolator wall, like we see on the picture on the right side below. Finally, here we see the end result for this flexible isolator, which is in operation at the customer facility. As you can see, the operator can work with almost no PPE because he is protected by the isolator. According to different measurements we made, a containment level of at least OEB5 is reached by this isolator. For the next process steps like granulation, sieving, drying, again sieving, blending, compression, and coating, we proposed to use a single-use transfer bag system like on this conceptual drawing. This transfer bag is having two connections, and with the interface on top, the transfer bag is connected to the dispensing isolator as shown before. Afterwards, the product is transferred to the next machine, connected by the interface below to discharge the product. This transfer bag is equipped with a special flange which we call Safeboard. The special feature of this Safeboard flange is that it allows to connect several bags on top of each other on the same port without opening the process. The whole system is designed to reach a containment level of at least OEB5 and therefore fulfills the OEB4 requirements of the customer. Because the API here is in direct contact with the bag, the fill material of this bag can be customized as well. This means the bag can be made of a customer-specific fill material with appropriate approvals like FDA, EP, or USP. And it is designed for manual handling with volumes from 5 up to 40 liters. Here on this slide, we can see how the bag is connected to the equipment to charge the API into the bag. So this is the first step. The transfer bag is connected to the machine, then charged with the powder. After that, the bag is separated with the SafeSeal crimping system. And the important step is the step 4, because what we can see here is the remaining piece from the previous bag who was already charged with powder. And this is the remaining piece, and the new bag can be really connected on top of the old one. And with the side pocket, we can remove the previous piece from the old bag into this pocket, and then we can charge the new bag. And the same applies for the discharging the API into equipments. I will show you a video later on to explain the connecting procedure in detail. Both operations, charging and discharging, can be repeated on every equipment and thus allows a continuously closed process. Finally, here we see the final result with the Safeboard transfer bag system in operation at customer facility. I'm not sure if you can see it here on the picture rightmost, but there are already the compressed tablets to discharge into the coater. All the process explained before is made by single-use containments. But of course, it has also some advantages and disadvantages to consider while planning a containment solution for a dedicated process. On the plus side, we have the low investment costs. It's very well customizable. We have very ergonomic handling, reduced cleaning costs, and therefore we also save time. On the negative side, sometimes the fill material is not resistant against solvents or temperatures. Sometimes it's difficult to work if there is some positive or negative pressure. Then we have some limitations for using in ATEX area depending on what fill material that we use. And then we have the higher consumable costs. The presented single-use project has been summarized by the customer as follows. So we have a successful implementation of the manufacturing process with OEB4 substances. We had a collaboration with the customer from idea to production. The risk assessment must be carried out individually and is strongly dependent on API properties as well as the manufacturing process. And containment solutions helped establish the process for available devices. And finally, I would like to show you the video announced before. It will give you also an overview of the process that I explained in the previous slides. Here you see the setup with the single-use isolator. On the right side, we have a ventilation system to do a venting of the environment from the isolator. We have the balance here where we can connect the transfer bag to make portions. On the back side, we have a big connection to connect the drum, which brings the API. First of all, the isolator is vented. After that, we can connect the drum by a special connecting sleeve. Take out the product bag with API. After that, we connect the Safeboard transfer the bag system. Remove the previous piece from the previous bag. Open the bag inside the isolator and take out the product and make the portions. After that, separated by Safeseal crimping system, transferred to the next equipment. And after that, the product is discharged into this equipment. And finally closed and separated again with the Safeseal crimping system.
Okay, so I think we could quit our webinar. So I want to thank Michael. I want to thank our audience. It was really our pleasure to keep this webinar.